Assalamu alaikum. Hello everyone. This is actually an exercise. We have two recursively defined sequences. So let U1 be a real sequence defined by the formula U0 equal to 1 over 4 and UN plus 1 equal to UN square plus 1 over 4 for n in n. The first question, show that the sequence UN, so the first question, show that UN is greater than 0 and less than or equal to 1 over 2. Indeed, one has U0 equal to 1, 4, which is strictly less than 1 half, so it is less than or equal, and strictly greater than 0. We suppose by induction that UN is less than or equal to 1 half and greater than 0, and we prove that UN plus 1 is still less than or equal to 2 and strictly greater than 0. How we can do this? Very simple. We have by induction that UN is between 0 and 1 half, so UN square is less than or equal to 1 over 4 and greater than 0. If we add one quarter 1 over 4 to both equalities, we get 0, less than 1 over 4, which is less than UN square plus 1 over 4, which is less than or equal 1 over 4 plus 1 over 4. This is equal to 1 half, and this is UN plus 1. So we proved that UN plus 1 is between 0 and 1 half. This means that this formula is true for all n in n. The second question, show that UN is an increasing sequence. The second question, show that UN is an increasing sequence. One has or we consider as this sequence is an additive sequence to show that it is increasing or decreasing or non-increasing or non-decreasing. We consider the difference between the successive terms UN plus 1 and UN, which is equal to UN square plus 1 over 4 minus UN. Actually, this difference UN, it is equal to UN minus 1 half square UN square minus UN plus 1 quarter, which is greater than or equal to 0. Thus, UN is non-decreasing sequence. This is the question. The third question, deduce the nature of UN and find its limit if it is convergent. what we have, we have, so the final, we have un is non-decreasing and un is above bounded by 1/2. Using monotonic theorem, we can deduce that un is convergent. un is convergent if un converge to L, un plus 1 converge to L, un square converge to L square plus 1/2. So the limit should verify this equality. But this equality can be transformed to L square minus L plus 1/4 equal to 0, which is equivalent to L minus 1/2 square equal to 0. This means that L equal to 100. So our sequence converges to the final limit, which is L equal to 1/2. The second question in the same topic, we consider a sequence which is defined by I mean Vn, V0, here we consider a sequence Vn, V0 equal to 1 quarter and Vn plus 1 equal to Vn square plus 1/16. The first question shows that for all n in n, the first question show that for all n in n, one has 1/16 less than or strictly less than Vn, which is less than 3/4. Yeah, this is the first question. We have, by hypothesis, that V0 is equal to 1, which is less than 3/4, and strictly great 1/16. We can add V1, we can verify for V1, but it is okay. So you have the right to verify. You can start proving the by induction the formula. Yeah, V1 equal to V0 square 1/16 plus 1/16. This is equal to 1/8, which is less than 3/4 and great strictly than 1/16. So V1 verifies the double inequality, the strict double inequality. We suppose that Vn is less than 3/4 and greater than 1/16. Yeah, 1/16. If it the square root function on positive numbers is an increasing function, so this implies that 1/16 square is less than or equal, strictly less than Vn square, strictly less than 9/16. This implies that 1/16 16, 3, 9, 6, 1, 6, 5, 2. 256. So we have 1 over 256 less than the n plus 1 over 16 less than the n square plus 1 over 16. So we suppose that this is true. We suppose that this is true, which means this, and we try to verify that the n plus 1 square, the n plus 1 is still between 1 over 16 and 3 over 4. Is it less than 9 over 16 plus 1 over 16? This is actually the n plus 1. From this side we know that this is greater than 1/16, so 1 over 16 is less than 1 over 256 plus 1 over 16, which is less than the n plus 1. This is the n plus 1, which is less than 10 over 16, which is equal to 5 over 8. Is it less than 3 over 4? So we have 5 times 4, it is equal to 20, and 8 times 3, it is equal to 24. So 24 is strictly greater than 20. This is true. So we want to verify that this double inequality, still double inequality, it is true. So we can say, as a conclusion, we can say that Vn is less than 3 over 4 and greater than 1 over 16 for all n in n O. What is the determine the monotony of Vn? To deal with this question, we consider Vn plus 1 minus Vn, which is equal to Vn square plus 1 over 16 minus Vn, which is equal to Vn minus 1 over 4 square, Vn square minus 2 over 4. So what we can do, we take here just to save this term, Vn minus 1 over 2 power 2. This is equal to Vn square minus Vn plus 1 over 4. This 1 over 4. This one and this one are here. We add 1 over 16 and we take off 1 over 4. So plus 1 over 16. 1 over 16 is this one. But to take off, we take off 1 over 4. 1 over 4. 16 here, and here we have 5, which is equal to Vn minus 1 over n square minus 3 over 4. How about this? How about this formula? We know that Vn is between 1 over 16 and 3 over 4. So Vn, yeah, I need a moment. I need here a moment. Since I didn't prepare the exercise, so is like this. Here we have Vn minus 1 over 2 square minus 1 over 4 plus 1 over 16. We have the information that Vn is less than 3 over 4 and greater than 0 for all n in n. And here we have this formula. Vn plus 1 minus Vn is equal to Vn minus 1 over 2 square minus 3 over 4. So this is positive. This is always positive. Minus 3 over 4. Is it negative or positive? Since we have Vn square between 1 over 16 and Vn square is between 1 over 16. It seems that I struggle here. I need to decide the sign of the difference. This one is between 3 over 4. Why I take this way? Why I take this way? Why did I take this way? Vn square is less than 1 over 16. 9 over 3, 9 over 16. And now Vn is less than 3 over 4 and greater than 1 over 16. We take off minus 1 half, minus 1 half, and minus 1 half. In this side we get Vn minus 1 half less than. Here we have 4. 1 half, so we have 2, and here we have 4. This is less than 1 over 4, and it is greater than 1 over 16 minus 8 over 16, which means minus 7 over 16. Minus 1, 7 over 16. If we take both of them to the square, this will be greater than 0 but less than 4. 49 over 16, 20, 56. Minus, we take minus 3, so minus 3 over 4 less than Vn minus 1 over square minus 3 over 4, which is less than 49 over minus 3 over 4. How about the sign of this value? Here we have 4 with times by 4 here and by 4 here. Then with times by 16 here and by 16 here. 16, 16, which is less than 0. Finally, it is less than 0. This means that this sequence is decreasing. I know that I did it in a very hard way. I am sure that other methods are most beautiful and quick than this one. The most important, it is less than 0, which means that Vn is non-increasing sequence. Vn is non-increasing sequence. So Vn is non-increasing sequence. It is non-increasing sequence. It is non-increasing sequence. It is bounded below and non-increasing sequence. So it is Vn is non-increasing and below bounded. The monotonic theorem gives us the right to say that Vn is convergent. Vn is convergent. The last question, deduce the nature of Vn and find if its limit, if it is convergent. The nature, it is convergent. Possible limit should verify L equal to L square plus 1 over 16. This means L square minus L plus 1 over 16 equal to 0. This means delta equal to 1 minus 1 over 4 for 1 over 4. This equal to 3 over 4. So the square root of delta is the square root of 3 over 2. The first solution, possible solution, the first possible solution is L1, which is equal to minus minus b means 1 plus the square root of 3 over 2 over 2, which is equal to 1 over 2 plus the square root of 3 over 2. And the second one is L2, which is equal to 1 minus the square root of 3, 1 over 2 over 4. This is negative, so is rejected. This is rejected. How about this one? Did it verifies the inequality? We have 1 over 2 plus the square root of 3 over 2. Is it greater than 1 over 16 or equal, and is it less than or equal to 3 over 4? We have to verify this as to be confident. Here we have 2 over 16. This is less than 1 plus the square root of 3. 1 over, this is true, it's okay. How about this side? We have 4 plus 4 the square root of 3 less than or equal to 6, and this is not true. The solutions this is not true. What is wrong here? What is wrong here? The limit should verify L equal to L square plus 1 over 16. This means that L square minus L plus 1 over 16 equal to 0. Solutions are delta equal to 1 minus 1 over 16. This is equal to 1 minus 1 over 4. This is equal to 3 over 4. So the square root of delta is equal to the square root of 3 over 2. The first solution, L1 is equal to minus b, so 1 minus the square root of 3 over 2 over 2. And this is equal to 1 over 2 minus the square root of 3 over 3. And the second solution is L2, which is 1 plus the square root of 3 over 2 over 2, which is equal to 1 over 2 plus the square root of 3 over 4. Yeah, this is the mistake. This is it negative? 1/2 0 1 over 2 minus the square root of 4. So here we have 4 and here we have 2. This is positive, it's okay. So it is positive. The second one, this one, we have 1 over 2 plus the square root of 3 over 4. Is it less than 3 over 4? So here we have 2 and here we have 4. We can cancel this. This is not true, so this cannot be a solution. Yeah, it cannot be the limit, but this one is the limit. It is the limit of the sequence. Why? Because it is greater than 2 and it is less than, it is greater than 1 over 16 and it is less than 3 over 4. We can check this easily, I think. Thank you very much. This is the consequences of someone who doesn't prepare his exercise previously. Thank you. See you next time.